Hello and welcome back. I hope you had a good weekend. It was Easter weekend. I can't think, but that's probably the only time that no one's been in church during Easter. So, anyway, I hope you guys had a good weekend and welcome back. We're starting our second week of our distance learning. We're going to wrap up the unit on circles and start surface area on Thursday. So, today will be an easy day. So, easy day back on Monday. We're going to review midpoint and distance formulas, which we've actually done on the second week of school. So this assignment should look pretty familiar to you, but now we're going to do it as it relates to circles, and it's going to lead us right into tomorrow's topic, which is the equation of a circle. People tend to struggle with the equation of a circle, so we're going to spend 2 days on it. We've done this assignment on the second week of school. We actually use a compass. You guys are going to wish, whether you love or hate those compasses, you're going to wish you had one for this assignment, but I'm going to show you how to do it without a compass, and that'll be good for you and kind of lead into tomorrow's topic anyway. So first thing we need to review is the Pythagorean theorem. So remember, this is a conditional statement. It says that if it's a right triangle, so if we have a triangle with a right angle here, and we do, then we know that the a squared plus the b squared is equal to the c squared. So what's special about the c? Why is this one all by itself and these two get added together? So the c is the hypotenuse, which is the longest side, and the two shorter ones are called the legs, right? And we notice what's in between the legs of a right triangle is the right angle. Gavin? Yeah, talking to you, Gavin. I can see you smirking through the camera. All right, so if we want to find out what is the length of the hypotenuse here, then we need to just simply square the legs and add them together. So that would be 6 squared plus 8 squared is equal to x squared, which is our hypotenuse. Whenever I put that in the calculator, we can put it in just like that. So we can do 6 squared plus 8 squared, which will give us 100. If it breaks it down like individually, you can do it that way just to see how it works, but that's 100. And then when we're done, we take the square root of that value. So because we don't want x squared, just want x. So we take the square root of 100. That was terrible, which is just going to be 10, right? So caret 0.5. So 100 caret 0.5. That's how I like to do a square root because it's the 1/2 power. It's going to be 10, right? We already knew that. Okay, so well, it's weird. Try this again. There we go. Okay, so x is equal to 10. Get all that stuff out of the way. All right. So how does this relate to circles? All right. This is just this exact same thing we just did with the Pythagorean theorem, but now it's on a circle. So what do you notice here with this circle? What's special about the hypotenuse here? So this is a diameter. And the hypotenuse will always be a diameter when we have a right triangle that's circumscribed by a circle. So that's because of Thales' theorem, right? So if the central angle here is 180 degrees, it's a semicircle, and then half of that, our inscribed angle, is going to be 90 degrees. So every single Thales theorem, right? Every single right triangle with a hypotenuse length of diameter exists on the semicircle with the third point, the vertice on the semicircle, which is pretty cool. So on this one, if we want to find out, if I have two endpoints of a diameter and I want to find out how long the diameter is, all I have to do is break down the components. So a squared plus b squared is going to give us a c squared. So it's really just the Pythagorean theorem. So another way that we look at this is with the distance formula, which is the same thing as the Pythagorean theorem. So if I was trying to find c, I'll do c squared is equal to a squared plus b squared. Now, how do you find out what a squared and b squared are? Well, a squared and b squared are going to be the distances between the two parts. So how long is this distance along the x-axis here? So if I'm going from -3, see the -3 on the x-axis, all the way over here to the +4, that's going to be how long our x component is. Then the y component, the b, is going to be from the -2, right here, -2, all the way up to the +3. So it's really just the difference between the x2 and the x1 and the y2 and the y1. And that's how we find those two values. So the a value here is going to be x2 minus x1. So 4 minus a -3, which becomes 7. And then the b value is going to be y2 minus y1. So -2 minus a +3, which would give us -5. So anyway, when we plug those in, we took the square root of both sides, and that's the distance formula. It's going to look just like that. And that probably looks familiar. So our distance, or c in this case is the distance, is going to be the square root of x2 minus x1 squared plus y2 minus y1. Now when I plug in the values for a and b, that makes it the Pythagorean theorem. But so what was our x2 minus x1? Well, that's 4 minus a negative 3. And our y2 minus y1 is going to be negative 2 minus 3. Now what happens when we subtract a negative? All right, so when we subtract a negative, it becomes plus a positive. So 4 plus 3, which is going to give us 7, and then 2 minus 3 is going to be negative 5. So we would get 7 and negative 5. Now, if I was doing this with the Pythagorean theorem, I would just look at how high this is, right? So if I'm going from a height of 3 all the way down to negative 2, what's the distance between 3 and negative 2? And I would just do a positive 5. But if we follow the formula, some of these are going to be negative sometimes. But that doesn't matter, because what happens when you square a negative value? You get a positive, right? So let's put this in the calculator, and I'll show you a word of caution. So this is a common mistake. So 7 squared, see if you can figure out what I'm doing wrong. So 7 squared plus negative 5 squared. Well, that was weird. Let's try that again. So 7 squared plus a negative 5 squared. There we go. And when I do that, I get 24. All right, that's not the answer. So whenever we put this in the calculator, I guess we'll break it down here. What's 7 squared? That's 49, right? And what's negative 5 squared? Well, when we square negative 5, that's going to be positive 25. So 49 plus 25 should give us 74. But when we put it in here, we got 24. So what did we do wrong? Well, I'll put it in the right way and then see if you can figure out why it works. All right, there we go. So the difference is when we do negative 5 squared, it only squares the 5 and then it makes it negative. So it did 49 minus 25 instead of 49 plus 25. So in order for it to know that we're squaring the whole negative 5, we have to put it in parentheses, just like we have it here. So this is a common mistake. I see that all the time when we do distance formula or Pythagorean theorem. All right, and that's kind of why I prefer just to keep it positive and use the Pythagorean theorem. All right, so when we do that, we get square root of 74, which is approximately 8.6. If we put that in the calculator. So 74, then we take the square root of that, so caret 0.5, which is going to give us 8.6 approximately. All right, so another example, we'll do distance formula. We're going to go from negative 3 to 6 and from 8 to negative 4. So the first thing we might do with the distance formula is we label our ordered pairs points 1 and point 2. So if we do x2 minus x1, that's going to be 6 minus negative 3, and then negative 4 minus 8. 6 minus negative 3 is going to become a positive 9, and then that would be negative 12. So we have positive 9 squared plus negative 12 squared, which was going to give us 15. Now, what if we switch the order of the x's and y's? What if we did, this is our x2, or our second order pair, and this is our first order pair, our first and second point? Well, when we do that, all it does is switch the order between those two. I guess I need to move this one out of the way. So now instead of 6 minus negative 3, it's negative 3 minus 6, and it switched the order of these two as well. And so now instead of 9 and negative 12, we get negative 9 and positive 12. But when we square them, again, the negatives become positives anyway, so we get the same exact answer of just 15. So it really doesn't matter the order in which you put those in, because when we change the order across subtraction, all it does is give us the opposite, like from 9 to negative 9, but when we square it, it doesn't matter. So the way I would do this problem is just looking at like the Pythagorean theorem. So if I'm going from negative 3 all the way to positive 6, if I go from negative 3 to positive 6 on the number line, how far is that? So you're not going to subtract those, you're actually going to add them together, right? So the absolute value. So if I'm going from negative 3 to 0, that's 3 in this negative direction. And then from 0 to 6 is another 6. So 3 plus 6 is going to give me altogether 9. And that's where I'll get this 9. And then to go from negative 4 to positive 8, we're going from negative 4 all the way to positive 8. So there's 4 in the negative direction and then 8 more in the positive direction. So adding those together is going to give us 12. So 9 squared plus 12 squared. And I wouldn't deal with the negative whenever I'm doing the distance anyway, which gives me 15. All right, so the only other thing I need to show you is the midpoint formula. This one looks familiar too. So we're going to add the x's together and divide it by 2, and then add the y's together and divide by 2. So what mathematical operation are we doing whenever we add two things together and divide by 2? What do we call that? So it's called the average. So from statistics, that's our average. If we added 3 things divided by the number of things of 3, that would be the average of 3, or whatever our sample is. All right, so in this case, we basically are just finding the average x component and the average y component. So we can add the x's together and add the y's together and divide by 2. So let me show you visually what that looks like. This is kind of cool. So in green here, those are our x components. So that's like our domain. So we're going from the very least of 1 all the way to the highest x, which is 5. So our domain is from 1 to 5. Now the question is, what's the average of those two? So if I'm going from 1 to 5, when I add them together, I get 6. What's halfway between, what's half of 6, which is 3, right? So the average in between those two, like if you collapse them together from 1 to 5, halfway between those two is going to be 3. So there's our midpoint right there. All right, then if we do the average of the y's, if I'm going from a range of 2 to 4, halfway between 2 and 4 is obviously going to be 3, right? So 2 plus 4 is 6, half of 6 is 3. So this is what it would look like if you plug the values in the formula. So 5 plus 1 is 6, divided by 2 is 3, and then 2 plus 4 is 6, divided by 2 is also 3. So graphically, this is what's going on. It's kind of fun to see it in that way. All right, so how will we use the midpoint formula when we're dealing with circles? So on a circle, let's say I give you 2 endpoints of a diameter, which is a pretty common setup. So I tell you that -5, 0, and 1, 0 are both endpoints of a diameter. And I want to find the center of this circle. Well, you can probably guess where it's at, right, when you have it graphed out. But if you have to find the averages, we're going to do the average of the x. So from -5 to +1, that's going to give us -4. Half of -4 is -2. So -2, 0 is going to be our midpoint. And then 0 and 0, 0. Half of 0 is going to be 0 still. So our midpoint is a -2, 0. Now that we know the center and we know we can find the radius, we can find all the other possible points. And that's what we'll be doing tomorrow when we do the equation of a circle. All right, so that was it for the lecture today. So it was like 12 minutes. It wasn't too bad. Kind of felt like I was dragging along there for a while because this stuff is so basic in review. But if you'll go ahead and get out your assignment, we'll go through most of them, but almost half of them together. So on number 1, let me look at my assignment over here. Got dual monitors going. It's pretty cool. So we want to use the midpoint formula, which is the average of the x and the average of the y, to find the center of a circle given 2 endpoints of the diameter. So if you want to go ahead and graph them out, if you have a ruler, that'll be helpful. You can use any straight edge surface as a ruler, as an alternative if you don't actually have a ruler. Be creative. So if we go from -2, 0 to 8, 6, if you want to graph those out, remember this is our x and our y. So -2, 0 goes over 2 and then up 0, and then 8 and 6. So we can graph those out. We can draw the line in between those. Remember, those are going to be our diameter. So that's going to be the diameter. We want to find what is the center of the circle. So the center is going to be the midpoint. You can probably guess where it's at, just if spatial reasoning skills there, which is pretty cool. So let's go ahead and do our averages of the x's and averages of the y's. So -2 plus 8 is going to be 6. Half of 6 is 3, and then 0 plus 6 is also 6, and half of 6 is also still going to be 3. So -2 and 8 is 6, half of 6 is 3, and then 0 and 6 is 6, and the half of that is 3 as well. So that's going to give us a midpoint at 3, 3. If we graph it out, we can see that. Now, one of the things that we did at the beginning of the year is then we would take our compass, and once we knew the center and the radius, we could draw the circle because we know the same distance, any equidistant point from the center is going to give us our all the set of all points that are equidistant from the center gives us the circle, right? So it's kind of cool when we have our compass, we can actually use it to check our work to make sure we found the actual center. Because if we chose our center wrong, let's say we did for, I don't know, there's no other like nice and easy point, but let's say we put it right here. So 4 and somewhere about 3.5. Oops, not what I was trying to do. So if we chose this point, then when we try to draw our circle, it didn't work. Because this wasn't actually the midpoint. It wasn't equidistant between the two diameters. So anyway, kind of cool. That's what we did the second week of school. All right, on number 2, we got 6, -2. So over 6 down 2, and then -4, +3. So left 4, up 3. We want to find the midpoint. You can probably guess it's somewhere in here. This one's a little tricky though. So let's go ahead and use our formula. So we're going from 6 and -4. So 6 plus -4 and 3 plus -2. So 6 plus -4, or -4 plus 6 is going to be 2. Half of 2 is 1. So first one's 1. And then 3 minus 2 is 1. 1 divided by 2 is 1/2. So our midpoint is 1 and 1/2. So we're going over 1 and up 1/2. And that should be our midpoint if we did it right. So I'm going to take my compass. You don't actually have to graph out the circles here until we get on the back side, because you guys don't have a compass, so that would be kind of difficult to do. But yep, that worked. So we found the midpoint between the two endpoints of the diameter, which is the center of the circle. We located the center. All right, number 5, 0, 0, and 12, 5. So on this one, the 0, 0 makes this kind of easy because when we add 0 to anything, it's just going to be the anything. So we just divide those two values in half. It's actually kind of like a scale factor if you want to think about it. But on number 5 now, instead of finding the midpoint, we're going to find the distance. So we can label our points here. We can label this our first ordered pair, and this could be our second one. So we have our x1, y1, and our x2, y2. Or if you want, you can just do this with the Pythagorean theorem, because we already have it graphed out, so we know what our x's and our y's are going to be. All right, so on this one, we got 12 and 0, so x2 minus x1 and y2 minus y1. So 12 minus 0 and 5 minus 0. So it's 12 squared and 5 squared. And you can just put that straight in your calculator as well. So we're going to do 12 squared plus 5 squared. And then we can take the square root of that, which is going to give us a diameter of 13. Now the question actually asks for the radius. So we know the distance here is going to be 13. Well, the midpoint is going to be 6, 2.5. But so if the whole thing was a distance of 13, then what would the radius be? So if the whole thing was 13, the radius is going to be half of that, which is 6.5. So when you're looking at your answer bank and you don't get what you got from the calculator, remember you found the diameter, and to find the radius, you just have to divide it by 2. All right, number 6, we're going from -2, 2 to 6, -4. So we can do x2 minus x1 and y2 minus y1. So 6 minus the -2 and -4 minus +2. So 6 minus the -2 is going to be +8. And then -4 minus 2 is -6. When we square those, remember when we put this in the calculator, we have to put it in parentheses. Or if you want, you can just do the absolute value of that. So we're going to do 8 squared plus 6 squared. Because when we square a negative, it's going to become positive anyway, which is 100. Square root of 100 is going to be 10. So if the diameter is 10, the radius is going to be 5. And if we found the radius here, the radius would be a distance of 5. It's a 3, 4, 5 Pythagorean triple. All right, on the back side, we got 6 problems here, and they want you to solve for both the radius, the midpoint, and then graph it out. So yeah, we do have 6 problems there. Okay, so on number 9, graph out 1, 1, and 11, and 7. Then to find the midpoint, you can probably guess it's somewhere around there. Somewhere, okay? But if we want to be sure, we could just graph out and find the average of the x and the average of the y. So what is 1 plus 11? It's going to be 12. Half of 12 is 6. So it's going to be along the line over 6, and then the other one has to be up 4, right? So you can do the midpoint formula, and we get a midpoint of 6, 4. Now that we have scrapped out for the midpoint, we want to find the radius. Well, once we know the midpoint, we don't actually have to do from here all the way to here to find distance. You could just do this part right here if you wanted to, which I guess I'm going to go ahead and do. I'll graph it out like this. So we're going up here, and then we're going over there. So if I graphed it out, this basically I found the delta x and delta y, the components, the x and y components, remember are vectors. So how high am I rising and how far am I running? So on this one, looks like I am going up 3 and I'm going over 5. Okay. So if I want to find the radius, all I have to do is the Pythagorean theorem. So 3 squared plus 5 squared, and then take the square root of that. So we got 3 squared plus 5 squared, then take the square root. All right, so it's approximately 5.8, which should be, yeah, 5.83 is one of your answers. All right, so what did we just do? Well, we did the distance formula, and then we divided by 2, in other words. So 10 and 6, but I got 3 and 5. Why did I get 3 and 5? Well, because I was doing it from the midpoint to get the radius instead of doing the diameter. It's the same method. Anyway, then half of that is going to be approximately 5.3. Now what I want you to do is to graph it out. Now, we could graph this out with a compass, which would be kind of nice, but I want you to know how to do it by hand as well. So if we have these 2 points, can we draw a circle or do our best to draw a circle? I bet you'd love to see me try. I'll do it at the end. So first, let's plot some more points. So if we know that this has a radius of 5.83 approximately, well, it has components of 5 and 3. So instead of going up 5 and or up 3 and over 5, what if I would have gone up 3 and then to the left 5? So I can move this point all the way over here. Wouldn't that be the exact same distance? So if I go up 3 and over 5 or up 3 and right 5, well, it would. And I could actually draw that out if you want to see it, but we would have components of over 5 and up 3, which is the exact same distance, this exact same radius as this triangle here. And I didn't necessarily mean to do this, but now that I've done it, it's actually kind of cool. Struggling here. Okay, so what does this look like to you? If you see those 2 triangles, you see what's going on there? So we actually have a 90-degree clockwise rotation going on here, or counterclockwise if you go from the other direction. Same thing if I drew this one out here. So if I go down 3, let me actually use my buttons. There we go. So if I would have went down 3, no, that's not it. There we go. So if I go down 3 and then I go over 5, we also could have gone over 5 and down 3. So usually when we do our rotations, we don't go in all 4 quadrants because it looks a little bit weird. But because we rotated the whole triangle, I think it looks okay. I did it all in the same color, but anyway. So on this one here, those are our 4 points that we can use, and we know all those points have to have the exact same, exact same radius or distance from the center. And so this can actually help us draw our circle. So I'm going to try to draw a circle going through all those points. Don't laugh. That's not terrible. This will look better on your screen. How about that? That is like an amazing tomato circle. Here, let me cheat. Is that okay? I'm going to do it anyway. Yeah, this is why we love compasses. Because that's how we draw perfect circles. Let me change the color. Do a yellow circle. Wow, that's pretty cool. Okay, so why did that work? Yeah, that's exactly what mine looked like, right? Yeah, it's like a flattened tomato. All right, so it worked because it's the Pythagorean theorem, right? It has the same components, 5 and 3 gives us the 5.83 approximately, right? 3 and 5, 5.83 approximately. 5 and 3, 3 and 5. So it's actually a really cool problem because it's leading us into the equation of a circle discussion that we're going to have tomorrow. So how can we find the set of all possible points that make up the circle, right? Not just 4 points. I'll probably struggle with that, right? But if I wanted to find all the other possible points here, that would make up the same distance from the center of approximately 5.83 from the center point of 6,4. So we'll discuss how we do that and how we actually write the equation. Hint, there's going to be a lot of radicals that come into play. But and how to write that equation, and how to go back and forth from the radius and the center point and the diameter and center point and to the equation of a circle. So got that to look forward for tomorrow. So let me do another example. I'm just going to graph this one out, or I'll do it without showing it. But so on this one, if we're going to go from -3 to +3, that means the center's at 0. The average x is 0. So that's going to be at the point 0 and 1. So I can go over, looks like I'm going over 3, and then I'm going up 7. So instead, I could have gone over 3 and then up 7 in this direction. Okay. And I could do the same thing. I guess I didn't really give myself enough space here. I can do the same thing over here, which is actually kind of like a reflection, if you want to think of it that way. And then to draw your circle, you can go all the way around doing the best you can. I'm going to cheat and use the compass, but I really wish I could see your faces and your lovely drawings. When you guys try to draw a circle without a compass, it's quite comical. And that's why we have compasses, because it makes it really easy. But why did that work? Why did all 4 of these points end up on my circle? And are there other points that we could have used? Yes, there are. So if the components were 3 and 7, what if I went over 7 and then up 3 to this point right there? I think I've got more. Yeah, I do. Yeah, that would have worked. Or if we would have went over 7 and down 3. Ooh, something was off. Oh, down 3 actually goes to that point right there. Yes, that'll work as well. And the same thing on the other side. Yeah, those 2 points will work too. Here and here. Kind of guessing. That's in the way. Yeah. So all those should be on the circle. Looks like this one wasn't like entirely exact because I was off by 1. There we go. All right, so we'll discuss how that works and how we can find all the other points tomorrow. I kind of really want to like get into it now, but ooh, what is that point right there? Can you figure it out? How do we do that? I don't know. You'll just have to come back tomorrow. I'm already 27 minutes in. All right, so I will see you guys tomorrow. Hope you guys had a good weekend, and yeah, talk to you later.